Welcome all to this tutorial. Today I will open up a chapter on LVM or Linux Volume Management. Extremely useful. You will soon see what it is, how you can use it, and what is it that it is good for in general. So the good news is that it is not that difficult to master and the commands are not that complex. Now if we go ahead and introduce a new command, df or disk free, and if we do -h or -h, it will show us the available size on our disk partition. So you see that SDA1, this is a very nice tool as it tells you what percentage of the disk is occupied. So SDA1 has 43% usage. Apparently SR0 has 100% usage, but that's just the ISO file, so that's correct, don't worry about that. SDB2 has 10 gigabytes of usage, which is pretty much 1%, the partition that we have mounted, I do believe, in the previous tutorial. Now df you can just use to have a list of these mounted partitions and how much space is actually used on them, or what is the available space, so on. So you have the size here. So wait, let me just choose this one here, SDA1, or let's choose a normal. Actually, let's take the example of the one that we have created. So this one says dev SDB2. It says size 10 gigabytes. Right next to it, only 33 megabytes have been used, and available is pretty much 10 gigabytes again, because it doesn't actually show these small numbers because we practically haven't occupied almost any space on it. And I don't think that this is 1%. It's probably less. So it doesn't really matter. It says used, so the amount of space that is used, that is occupied, is 1%, and then it says mounted on, and it will show you the folder. It will show you the mount point here, so you see that the mount point is as we have specified it before. Again, another one of those useful tools that can provide you with all sorts of interesting information. Anyway, now one of the first things that we need to do if we want to see how the Linux volume management actually works and functions, because this is an important part of Red Hat and of pretty much any other Linux distribution out there, we first need to assign or change the IDs of our partitions so that they would be usable by LVM. In order for us to do this, we will need to jump into fdisk, just type it, fdisk dev SDB. We are going to mess around with SDB, and we will use the T option. It says partition number. Okay, let's select the partition number, but wait, before I do this, let me just type in fdisk-l. I just want to show you what do I intend to change so that you know that it has been actually changed. So you see dev SDB here. I will change the system IDs here from. You should see an LVM here pretty soon. So type in fdisk dev SDB, enter. I know the option that I want to use. I will use T, and it says partition number 1, 2. Well, I want to do it for both, but the second one is mounted. So let's go ahead and change it for the first one, and then we'll unmount the second one. Hex code. What could that be? Well, if you want to see the hex codes for IDs, you can just go ahead and press L, and there you go. You have these hex codes for the IDs of the. I've used actually this file to show you what sort of file systems can Linux read. And okay, that's perhaps not the best of examples, but definitely you can see a lot of these things here. No big deal. Anyway, let's go ahead and search for what we actually need. So let me just go ahead and scroll through this to see it. So we have NTFS, exFAT here. We don't really want that. FAT. We don't really need those either. It should be around here somewhere. I swear if somebody sees LVM, feel free to scream, but I'm not going to hear you. Somebody might. Okay, so we don't need swap, we don't need Linux, we need, there we go. So Linux LVM, we have found it, and the hex code for that is 8E. Okay, so let's type in 8E, press enter, changed type of partition Linux to Linux LVM. Let's see what happens when we try, let's see if we can actually change the partition, the system ID for the partition SDB2. So let's go ahead and do this and use 2 and type in 8E. Changed partition of Linux to Linux LVM. So let's see if this has taken place. Right changes. And it says, okay, so I get a warning. The partition table has not been altered. To reread the partition. Oh, okay, I didn't actually mess around with the partition table. That's fine. It says down here, warning, rereading the partition table failed with error 16, device or resource busy. The kernel is still using the old table. Type in fdisk-l, what am I typing in for you wrong? fdisk-l. And okay, so it has changed it, but you should definitely not do this. Unmount the system and then do it. Let me just go ahead and do it because we got a pretty serious warning there. So clear the screen. You mount mnt Udemy. Is it? Yes, it is. fdisk dev sdb. Yeah, my awesome typing. Fdisk. Okay then, so we need to change it for the second one. 8E, and we need to change it for the first one. 8E, and let's go ahead and write these changes. Excellent. So it says the partition table has been altered. It's all fine and dandy. We don't get any warnings or errors or anything of a kind. Everything should be fine. fdisk-l. If you get a serious warning like that one, if it says that it's still using something old or something of a kind, yeah, you should definitely go ahead and have a look at that and see what the problem is. I mean, obviously change it because something is a mess. We got the IDs, so it says AT, and it says here Linux LVM. Okay, now the LVM can actually use these partitions, and that's completely useless at this point of time because we really haven't done anything to the LVM. We really haven't done anything with the LVM itself. We've just changed it for these partitions. Now LVM at later stages will allow us to dynamically resize space on the drive. We don't need to know in advance how much drive do we need for partitions because we are able to resize it at a later point of time, and we are not, there is no need to like reformat the partitions or anything of a kind, create new ones to resize something. You can just resize it without bigger problems using a simple command. So you can resize the allocated space. You can resize the space quite easy, and you can do it all live. There is no need for downtime or anything of a kind on the server. This is especially important on the servers. For you as a regular user, it's probably completely relevant because you can restart the machine. But yeah, I don't really like turning off my machine. I don't really like resetting it or rebooting it. I think that the uptime on my machine and my laptop is 20-30 days, something like that. And it's functional. But as I said, it's not a big deal for home machines, but it is a big deal for big data centers or something like that. Imagine if Google had to restart their servers. everybody in the world who uses Google services would not be able to use those services for what, maybe 5, 10, maybe even 20 minutes, depending on the system and depending on what they're doing. Wouldn't that be ridiculous? Wouldn't that be stupid? Well, of course it would. That's why we have LVM, where you can resize things at any point of time that you feel like, as long as you have the permissions and no need for downtime or anything like that. LVM is also used for hot plug options or hot swipe options, where you basically are able to just pull the defective drive out or pull a non-defective drive out of the system and just plug a new one in. So hot plugs, no big deal. LVM allows for all of that. Now, in the follow-up tutorials, here I just wanted to introduce you to it, talk a little bit about it, and make some preparations that will come in handy in the follow-up tutorial. But in the follow-up tutorial, what we are going to talk about is the abstraction layers. So we will create the physical volumes. We will bundle them up. We will have SDB1 and SDB2, which will be put into a physical volume, and then we will create the volume groups. Well, we'll create one volume group because that's all we need, but you can create as many as you want, as many as your system allows you. And then as last, we will create a logical volume. I will also talk about what these things are, as well, as they are just layers of abstraction, but the picture is not always quite clear. And afterwards, you will be able to see how these things can be resized live on a system without any downtime or anything of whatsoever. It's quite simple. As I said in the beginning, you won't have to use any complex commands, long one-liners or anything of a kind. They will be pretty short, so no worries there. Anyway, I bid you all farewell and wish you a ton load of luck.